Hello, today I am here with the microcontroller based robot. It's a robot which uses Navia board. It's the main part of the robot. To speak frankly, it is the brain of the robot. And these are the two sensor circuits which you can see here. It has a sensitivity variable adjustment using a variable resistor, and also it has an op-amp amplifier. The board is an Avia based Avia company microcontroller. The microcontroller uses this Atmega 8, and this is the microcontroller, and this is a motor driver IC, and this is a decoder. What you can see here is a power supply circuit. When you connect the battery with this 9-volt battery, such as this one, you connect it with this using these connectors. And it is also a Atmega 8 microcontroller programming board. As to say, it's a programmer used to connect to the computer and just load the program which have written the Avia software. The Avia compiler. You can load the program to the Atmega microcontroller using this programmer. Once you load the program, what you need to just do is to remove the programming board which is connected using these connecting wires, and just connect the battery in place and just switch on the power supply circuit and the motor switch. This switch is used to switch on and turn on and off the motor, and this switch is mainly for power supply switching on and off. So once you do all this, you can just run your robot and see its marvelous performance. So I am here with the demo of line following robot and pattern following. You can code any pattern of your wish in the software, in the compiler, and just load, and you see the robot following the same pattern when you place it on the ground and switch it on. And to say about the line following robot is a bot which basically follows line, like a dark line, for example, of an insulation tape of color black. If you place a strip of insulation tape on the ground or on the floor, in any pattern, in a curved or crossway or any pattern, the robot follows it fantastically and intelligently. It follows the pattern accordingly. The working of this robot is very simple. These are the sensor input which I told earlier. It's infrared, LED, and photodiode combinations. There are two sensors here, and the IC is used for amplifying the output signal of the sensor, and the output signal of sensor is interfaced to any one of the port of the microcontroller, and to another port the motor inputs are placed. These are the yellow one is the geared motor which you can find here. The geared motor is especially useful for reducing the RPM, so that the robot moves smoothly on the ground and doesn't stall very fast, which may lead to some unwanted output. So the the gears reduce the RPM to a level so that the robot moves smoothly on the ground. And this here you can see the output input supplies to the motor. These are the wires which supply current to the motor, and it's connected to 4 pins. These 4 pins, 2 pin each for one motor. It's a pair of 2. So these inputs of the motor are also connected to another port. One port is used for connecting the sensor inputs, and the other port is used for connecting the motor outputs, so that when the robot follows line, if there is any fluctuations in the sensor output, then accordingly the wheels, I mean the motor which has been connected to the wheel, it stops or runs accordingly. For example, assume this strip of black line, a black line. So assume that the motor is running straight, the robot is running straight, and by some actions it has been displaced, and the motor somehow has moved to a side. So you can watch here that one of the sensors, among the two sensors, one of the sensor has come over straight above the black strip of line. But this sensor has a special property that it doesn't reflect the IR radiations which has been emitted from the white LED, which is an IR LED, infrared LED. It doesn't get reflected from the black surface, because you know that the black surface usually absorb all the light or radiations falling on it. So when it falls on a black surface as this, the sensor output will be low, because there is no reflection of the rays to the photodiode. So as soon as the sensor output is low, the motor which is placed on the same side will be made low using the microcontroller. That's the intelligence, that's the simple intelligence what we have coded in the microcontroller. So when this motor is off, when the particular motor which is on the side of the sensor is off, this part of the boat stops, and only the wheel which is rotating is the opposite wheel. So as only this wheel rotates, the robot ultimately it turns to the opposite side. So as you can see, again it follows the path. In the same way, if there is any overlapping of the strip or this sensor, this particular wheel stops, and only the wheel which is rotating is this one. So the motor ultimately turns to the same side. So I will hereby show a demo video of this, the working video. You can make it more clear how the motor works, and how it follows the line more practically than I say. You can watch it clearly. So please watch my demo in the next video, which is a line following robot demo. Thanks for watching the video. Signing out, Blesson Ishovergis.